Hello everybody, this is Mr. Ainsworth. We're going to get into section 3 here of chapter 3 and cover what's called the first derivative test. In general, it is very difficult to locate the relative extrema, meaning the relative maximum and minimums, without the graph. And so calculus is needed to determine that. Because even with a calculator, it can only give you approximations. So we need to come up with a way to determine the relative min and max of a function without the graph. Let me illustrate why. Okay, let me just draw a little picture here off to the right. Suppose we have a function that looks like this. We'll call that f. All right, and we see that it's unbounded. It's on an open interval here, and it continually goes up and up and up, and it continually goes down and down and down with no end. And it has no absolute min and max, but it does have what's called a relative maximum here. Okay, we'll call that at C1, and this maximum, this relative max, is the y value at that point, f of C1 equals f of C1 right here. And it occurs at the top of the hill. And we know it occurs at a critical point. But without looking at the graph, we would have no idea whether it represents a relative max or min. We need to come up with a method to determine that. And that's what the whole point of the lesson is today, and what the first derivative test is all about. We also need to figure out a way to determine that we have a relative min at C2 in this case. And the relative min is right here, the minimum value, and that'd be f of C2 in this case, and that'd be what's called a relative min. But without the graph, how do you locate those, and how do you find those without the graph, without the T84, without any technology? Okay, that's where the first derivative test comes in. Okay, we know that we know how to find critical points, and it's the zero of a derivative, meaning where we take f prime and set it equal to 0 and solve for c. That's what we call a zero derivative. And we know that local extrema, these are called extrema here in general, okay, occur at the critical points, which I abbreviate as CPs. So it's our job to find C1 and C2 first, and that's easy. We just set the first derivative equal to 0, and then we need to come up with a way to determine whether it represents a relative min or max. Okay, we have three possible cases, and let's go over all three, one at a time. Suppose we have a portion of the function that looks like this right here. We'll call that f right there. There's our function. And notice at the very top of the function, right up here at the very highest point, at let's say c right here, where c represents some critical point, okay, represents a relative max. Okay, how do you know using calculus or a derivative, or that it determines what's called a relative max? Okay, what we do is take a look at the sign of the derivative to the left and right of the critical point. So let's take a look at the left side of c here, and let's take a look at this point right here. And that x value is to the left of c. The slope of the tangent line is right here, and we notice that f prime, where the slope of the tangent line is positive, it's greater than 0 there. If you move along the function to the other side and take a look at another point on the function right here, you notice that the sign of the derivative, f prime, went from positive to negative. It's less than 0. It's negative right there. And so it's positive slope on the left, and the derivative, or the slope of the tangent line, is negative on the right. And notice that it switched sign there. When the derivative is positive, it indicates that in that interval that the function is increasing. It's increasing to c. As you approach c, the function is increasing. And out to the right of c, you'll notice as you go away from c, the function is decreasing. And that's what negative means, is that when the first derivative is negative, it's decreasing on that particular interval. So the first derivative can give us a lot of information here. It can tell us where the function is increasing, if the first derivative is positive, and where it's decreasing, where the first derivative is negative. Now, if there's a change in sign like what we have here, we have either relative max or min. In this case, we have relative max, because if a function goes up, increasing, and then hits some maximum point and then comes back down, it's got to represent a relative max. So in other words, we say if f prime, okay, which represents the slope of the tangent line, if f prime changes sign from, let's say, positive to negative, okay, then c comma f of c and this is your max now, okay, represents, okay, a relative max. Some people call that local, okay, local max. Okay, we in this class, we're going to use the term relative max. So if there's a change in sign from positive to negative, the function must go up and then back down, which it kind of looks like a hill, and we have a relative max at the very top. That's one possible case. The next possible case looks like this right here. We have like a valley, and let's say that's F right here. And we have a low point in the valley right about here at C, where C represents some critical point. And in this case, we have something different happening here. On the left side of C, the function is decreasing as you approach C. Okay? And let's take a look at this point right here. We notice that the slope of the tangent line is negative there. F prime is less than 0 as a negative. And then to the right of C, well, the slope of the tangent line is positive, so we say F prime is positive there. And we also have a change in sign, but this time to the left of C, as we approach C, the slope of the tangent line is negative, and then it changes to positive. So it must be decreasing on the left side and increasing on the left side, the right side. And so in this case right here, if the derivative, if F prime changes sign from negative to positive, then it indicates that C comma F of C represents, okay, a relative min in this case, relative minimum. Okay, and this right here, this point right there is what's called a relative minimum, because it goes decreasing and then increasing. It goes down and then back up. Okay? So if you have a change in sign to the left and right of your critical point, you must have either a relative min or max. Now sometimes it doesn't change sign, in which case you have something like this. Okay, suppose that's F right there, kind of like a x cubed function or a cubic function. They kind of look like that. And tangent functions look like that. Let's suppose we take a look at this function, or excuse me, this point right here at C. That's called an inflection point for cubics, because it changes concavity there from concave down to concave up, concave down here and concave up here. And notice that no matter where you draw your tangent line, like right here, and right there, F prime is positive. And then right here, F prime is positive. No matter where you draw F prime, or the tangent line, it never changes sign. It's always increasing. So this function is always increasing from left to right, and it doesn't change sign. So we say that if F prime does not change sign, okay, at C, then C comma F of C does not represent a relative min or max. Okay, does not represent a min nor a max, Okay, it's neither one. Okay, so you only have three cases. So what we're going to have to do on all these problems is take a derivative and find the critical points first, and do what's called a first derivative sign analysis to determine on what intervals the function's increasing or decreasing, and then from that, what the relative extrema are. Okay, so the first thing you do is you got to find critical points. Okay, and that's when you set the first derivative equal to 0. Okay, so let's get F prime, and that's going to be equal to 2x minus 8. You set that equal to 0. And you solve that, you're going to get x equals 4. And that's a critical point of the function. And then you do what's called a first derivative sign analysis. First derivative sign analysis. Okay, and so that's called F prime. And we're going to draw a little graph right here. And we're going to plot for the critical point. And we're going to see what happens to the left and right of that. If it changes sign, then we have extrema. If it doesn't change sign, then we don't have extrema. So what we want to do is evaluate the derivative at a point left of 4, and then evaluate the derivative to the point at right of 4. So left of 4 is 3, so let's evaluate f prime of 3. And that's going to be equal to 3 squared minus 8 times 3 plus 4. That's 9. Excuse me, I didn't say that right. I got to revamp that. I looked at the wrong function. Evaluate the derivative. Don't do what I just did. We got to evaluate the derivative, and the derivative is right here. Okay, so let me start over again. F prime of 3 is 2 times 3 minus 8, and that's 6 minus 8, or negative 2. That's obviously negative or less than 0. And so what we do is we symbolize that by putting a negative sign here. And so what's happening to the left of 4 here is that the function is decreasing. Okay, it's going down as you approach 4. Okay, and what's happening on the right of that? Well, let's pick a number bigger than 4, like 5, and let's evaluate the derivative at 5. And we get 2 times 5 minus 8, and that's positive 2. That's greater than 0. So what we say is that it's positive there, and that indicates that it's increasing. Okay, it's increasing to the right of 4. So it goes down, hits a critical point, and then back up. So if it goes down and then back up, it's got to be a relative min. Okay, at 4 comma, and then whatever the y value is. How do you find the y value when x is 4? Well, you evaluate f of 4 back into the original function. So we use this one here. So we have 4 squared minus 20, let me see, 4 times 8, 32, okay, plus 4, 16 minus 32 is negative 16, plus 4 equals negative 12. So we have a relative min at 4 comma negative 12, and the min is exactly negative 12. And you can see it on the graph. It's right here. Okay, right there is the relative min. Okay, notice that the slope of the tangent line is negative on the left, and right here, positive on the right. So f prime is negative on the left, positive on the right, which means it's decreasing and then increasing. Okay, in which case you have relative min. Now we're also trying to do this right here. We're trying to find the open intervals where f is increasing or decreasing. Okay, now in Algebra 2, you labeled this interval here x less than 4. Anything to the left of 4 is called x less than 4. In calculus, we describe it with an open interval notation. And we say that, well, first of all, there's negative infinity to the left and positive infinity to the right. And in open interval notation, we write it like this: negative infinity to 4. Open on both sides, because you can't contain infinity, and right now you can't contain 4 either, because, well, the slope is, it's not negative at 4, it's 0 at 4, because you have a horizontal tangent line at 4. Right there, f prime of 4 is equal to 0, so horizontal tangent line. So, and then to the right of 4, you used to call it x greater than 4, but in calculus we say that it's from open at 4 to what's called positive infinity. They mean the same thing. So when you describe this portion right here, the open intervals, you say the following. You say decreasing, okay, on the open interval from negative infinity to 4, and then you say increasing on the open interval from 4 to positive infinity. Okay? And that's what you're going to be doing for each problem. All right? And they go from, and all my examples go from easy to, to difficult. Okay? So let's try it again on example 2 and see what happens. Okay, the very first thing what we want to do is find the derivative, because we got to find the critical point. So find critical points, and that we do by taking the first derivative and set equal to 0. That's how you find any critical points. So here we go. F prime is equal to 3x squared minus 14x plus 11, and you want to set that equal to 0. And you're going to find your critical points. So let's try to factor this and see if we can. So 3x here, x here, 3x times x is 3x squared. I use the FOIL technique. First times first is first. Factors 11 or 111. And you want to adjust it so the inner and outer products are add up to negative 14. So that's 1x, and that right there is 33x. That's not going to add or subtract to negative 14. So I'm going to switch to 1 and 11. I'm going to put 11 here And I'm going to put 1 here. So here we go. Let's try it again. We got 11x plus 3x is 14x, but I want to make it negative. So we've got them both have to be negative. And then you set them both equal to 0. You solve. And you get 11 thirds and 1. Okay, now 11 thirds is 3 1/3. So you can see on the graph right here it's 3 1/3. And you go down, that's your C1, and then right here at 1, that's your other critical point. So my critical points right here and here, critical points are 3 1/3 and 1. They're going to give us our relative minimum max. But without the graph, how do you determine what you have? So what you do is you do a sign analysis. Okay? A sign analysis. So let's do that. First sign analysis of f prime. Okay? So here we go. We're going to plot 1, and we're going to plot 3 1/3, and we're going to check the signs in between these values. So we have 3 points that have something left of 1, in between 1 and 3 1/3, and then something to the right of 3 1/3, and just pick easy points to evaluate. Okay? And when I evaluate them, I'm going to substitute them into my derivative, and I have 2 choices. I can use the original derivative, or I can use the factored form of the derivative. I want to use the factored form. So I want to check, I'm going to check a point left of 1, like 0. 0 would be easy to check. So f prime of 0. So I put a 0 in here. 3 times 0 is 0. 0 minus 11 is negative. So I got a negative number there, times 0 minus 1 is negative. And that is equal to a positive. So it's positive here, or increasing on that interval. You can see that on the graph. The slope of the tangent line right here is positive. Okay, it's greater than 0. Okay, what's happening between these 2 points? Like a 2, right there. F prime of 2. And let's substitute it in here. You got 6 minus 11, that's negative. And then 6 minus 1 is positive. Negative times a positive negative, so it's negative here, and that means it's decreasing on that interval. And that makes sense, it's decreasing on that interval because the slope of the tangent line is negative there. Okay, negative slope. And then to the right of 3, you can pick 4, so f prime of 4, and that's going to be, let me see, 4 times 3 is 12, minus 11. Sorry about that. And then so 3 minus 4 is 12, minus 11 is positive. Notice that I'm just worrying about signs and not numbers here. And then 4 minus 1 is also positive. That positive times a positive is positive, so it's positive there, and that means it's increasing on that interval. You can tell that's the case. It's increasing here. You're going up, and the slope of the tangent line is positive there. F prime is positive. So what's going on? So from left to right here, it's increasing and then decreasing. So this is a max. So you have a max here. Now it's going down and then back up. You got a min here. That's how you interpret it. Okay, so we got a relative min. Okay, at 1, comma, and then we got to evaluate the function at 1 to get the y value. And then of course, whenever you evaluate a function, you evaluate the original one right here. And so you substitute 1 in there, and when you do get it, you're going to come up with 0. So 1 comma 0 is a relative min. Excuse me, not relative min. Relative max. I didn't read my writing correctly here. Let me just change that. Made a little minor error there. I didn't write down the right word. Relative max at 1 comma 0. You can see that at the graph. It's right here. And then what you're going to have is you're going to have a relative min. Okay, at 3 1/3. Comma something, and that something is found by taking that and substituting the original function. Okay, and you got to do that. So you got to substitute in, 11 thirds, and then go through the arithmetic, and it's going to be a lot of fun. Okay, it's going to be down here. Let me see this: -1, -2, 3, 4. I can't even read this. It's so small. Okay, but you just substitute it in there and come up with your y value. And then the last thing you got to do is you got to substitute you got to discuss your intervals where it's increasing and decreasing, and that is found by looking at the analysis here. Okay, remember this is a negative infinity, negative infinity here, and this is positive infinity here. So using interval notation, this interval where it's increasing is from negative infinity to 1, and then from 3 1/3 to infinity. So you just write that down. You got increasing on negative infinity to 1, and from 3 1/3 to infinity. And it's decreasing on the interval between the two from 1 to 3 1/3. 1 to 3 1/3. Okay, so that right there was required finding the extrema, and then we also had to find the open intervals where it's increasing or decreasing. We got a summary all right here. Okay? Should have given a little bit more room on the prep here, so sorry about that. But that's how it's done. Okay? And you're going to try that on each of the functions. Okay. The next one, we want to find the relative extrema from 0 to 2 pi. Okay, and so let's go for it here. So let's get started. We're going to have to find the critical points first. Alright, and so let's take a derivative. You get f prime is equal to 1/2 minus cosine x. Set that equal to 0. And that gives us 1/2 equals cosine x. So you got to figure out when is cosine x equal to 1/2. And that's at 60 degrees. And 240, or in radians, you want these in radians here, you want it in pi thirds and 5 pi thirds. So when you take the inverse cosine of 1/2, you get pi thirds or 60 degrees and 5 pi thirds in quadrant, excuse me, I didn't say that. Oh yeah, quadrant 1, and then quadrant 4 you get 5 pi thirds. 2 pi minus pi thirds gives you 5 thirds pi. So quadrant 1 and quadrant 4, that's where sine is positive. Okay, and those are your critical points. And now what you want to do is do an analysis on your derivative right here. We want to use this function here for your sine analysis. So first derivative, and you plot pi thirds here and 5 pi thirds here, and you check your intervals from negative infinity to pi thirds, and between the two, and then from pi thirds to positive infinity, and figure out what's going on. So to the left of pi thirds is pi fourths. So test f prime of pi fourths. And that's going to be 1/2 minus cosine of pi fourths. And that's going to be equal to 1/2 minus root 2 divided by 2. And 1 minus root 2 is negative. So this is going to be a negative number here. So it's less than 0. It's negative. So I'm going to put a negative sign here, and it indicates that it's decreasing on that interval. And in between these 2 points is pi, let's say. So pick something easy. So let's evaluate f prime of pi. And you get 1/2 minus cosine of pi. Cosine of pi is -1, so that's 1/2 minus a -1, and that's positive. So if it's positive, it's increasing on that interval. And then something to the right of 5/3 pi, try 7/4 pi. So f prime of 7/4 pi would be 1/2 minus cosine of 7/4 pi. Cosine's positive in quadrant 4, so it's going to be 1/2 minus root 2 over 2 again, and that's negative. So if it's negative here, it's decreasing on that interval. So what do we have? On the first interval, it goes down, it's decreasing, and then hits the critical point, and it goes back up. So we have a relative min here. And then it goes increasing and then decreasing too. So we have a max here. Okay. So we have the following here. Let me summarize here. And this is the summary of example 3. Okay. So what we have is we have decreasing on 2 intervals. We have decreasing on negative infinity to pi thirds, okay, and from 5 pi thirds to infinity. And then we have increasing on the interval between the two from pi thirds to 5 pi thirds. And then we have a min, a relative min, okay, at pi thirds comma f of pi thirds. And then we have a relative max at 5 pi thirds comma f of 5 pi thirds. Now these right here, you can find that just substituting the function, and you can find this one by substituting the function. And by the function, I'm saying substitute it back into the original, and you can evaluate that and get your y values. Those become the relative min and max. Okay? Number 4. We have the following here. We want to find the extrema of fx equals x squared minus 4 raised to the 2/3 power. And this is going to be a fun one because it contains a couple costs. So, let's see. I'm going to pause for a minute.